Okay, on to Properties of Gases, Lecture 2. Here what we're looking at is diffusion of gases. So what we'll want you to be able to do at the end of this is define Graham's law and explain diffusion. So what is diffusion? Diffusion is the movement of a substance from a region of high concentration to a region of low concentration. As gases diffuse, they distribute themselves throughout a container as if they occupied the total container. So it's a movement of something from areas of high concentration to low concentration. Gases have a lot of kinetic energy, meaning they have a lot of inherent energy in them. Gases have this kind of chaotic random motion that carries them around. Solids, on the other hand, they don't have a lot of kinetic energy, just that energy that's stored within them. Usually you have to do something to a solid to get it to exert energy. A liquid, kind of in between a solid and a gas, but has some amount of kinetic energy, but not near as much as a gas. So diffusion can occur in all states of matter. However, since kinetic energy is the driving force behind diffusion, which state of matter diffuses most rapidly? Well, if you answered gaseous diffusion, you are correct. Remember, it does depend on the concentration gradient, not necessarily on the volume differences. And we'll talk about this more because numerous factors affect the rate of diffusion of a gas through another gas. And it can be summarized by thinking about the diffusion rate will be affected by pressure, temperature, the cross-sectional area of which it's moving, the molecular weight of the gas, and the distance it has to go. So to think about the difference between density and diffusion, let's think about this. Why does a balloon float? Why does a helium balloon float, I should say? Is it based on density or diffusion? Well, helium is less dense than normal atmospheric air, so it floats because of the low density of the helium gas. Why does it stop floating after a few days? Well, what happens to these balloons? Yeah, that helium gas moves from an area of high concentration inside the balloon, diffuses out the rubber that the balloon is made of into the atmospheric air where it's trying to create an equilibrium. So it stops floating because of diffusion. Why does a Mylar balloon last longer? Not to mention cost more. Mylar is more dense, so it keeps those helium molecules inside of it better. It's harder to diffuse. It's harder for the helium to diffuse through the Mylar than it is a standard latex balloon. So, is it density or diffusion that makes our voice sound funny when we suck the helium out of that balloon? Well, if you think of that, sound is produced by the vibration of the vocal cords. That vibration doesn't change. What's changing is that the helium is lighter than the air, and so those sound waves travel faster. So we have an increase in the speed of the voice. We kind of get that Donald Duck voice. So because of this, it's both the density of the helium and diffusion, because it diffuses at a faster rate, because that lighter gas moves faster. So Graham's law helps qualify the gaseous diffusion rates. So simply stated, Graham's law is the rate of diffusion of a gas through a liquid is directly proportional to the solubility coefficient and inversely proportional to the square root of its density. So that leads us to the point where we have to, we're going to have to look at some of these density amounts. But the more soluble something is, and again, this is talking about a liquid, this is talking about the gas movement through a liquid, it diffuses faster the more soluble it is. So if we look at the higher the square root of a gas, we're going to lead to a slower diffusion rate. Again, because Graham's law states the rate of diffusion varies inversely to the square root of the molar mass of the gas. So a lighter gas will diffuse faster. A more massive gas will diffuse slower. So diffusion is based on that kinetic energy. The more kinetic energy, the higher the speed, or the higher the heat agitation that occurs.